Welcome everyone. In this video we are going to talk about how to find the square of a number, and we will be talking about some special number. First we will be talking about those numbers which are ending in 5, and then we will talk about those numbers which are less than the base and those numbers which are more than the base. In the next video I'll be talking about finding the square of any number through a process known as duplex method, right? So this is going to be a very interesting video, and to get the things right you need to watch it till the very end. In case if you are new to the channel, please do subscribe it. So let us first talk about how to find the square of a number ending in 5. So here the answer is written in two parts. First is left hand side part, and then we write the right hand side part, right? And LHS is calculated by multiplying the digit before 5 by the digit 1 more than that, and RHS is always 5 square, that is 25. So let us understand it through this example. Suppose we have to find the 25 square, then it will have two parts. One part will have 3 and it will be multiplied by a number more than 3, means 4, and so the left hand side will be 12, and what will be the right hand side? That is 5 square, that is 25. So the square of this number will be 1225, right? 1225. Let us look at some more example. So suppose I ask you find the square of 75. So the answer can be written in two parts. One is the left hand side part, where I will be writing 7 into a number more than 7, that is 8, and the right hand side will be 25. So what will be the answer? Answer will be 5625. Very simple. Here we have to find 405 square, so I will write 40 into 41, that is the left hand side, right? And the right hand side will be 25. Very simple. So 40 into 41 will be how much? 40 into 40 will be 1600, and then 40, so it will be 1640 and then 25. If I talk about 215 square, so I can write the left hand side as 21 into 22 and the right hand side is 25. So 21 into 22 will be how much? If I multiply 21 into 20, I will be getting 420, and then again 22, so it will be 462. I hope you got it. Let me do it quickly here. Suppose we multiply 22 into 21, so you can write 22 and then 44, so it will be 264. So the left hand side here is 462 and the right hand side is 25. So we can multiply, means we can square any number which ends in 5 just by this process. Okay. Now there may be a situation where we have to find the square of something like, suppose I ask you find the square of 9993 square, or find the square of 99992, right? These are a special number. Why these are a special number? Because these are near to the base, closer to the base. If you don't know what is base, then you should watch the first video in the playlist of Vedic Mathematics that I have uploaded. And just to quickly tell you what is the base. Base are those numbers which actually starts with 1 and ends in 0. So 10 is a base, 100 is a base, 1000 is a base, and so on. So suppose we have to find the square of a number which is near to the base. So I am going to discuss it in two parts. In the first part I will be talking about a square of those numbers which are below the base, and then I will talk about those numbers which are above the base. So what is the process? Here also the answer is written in two parts, that is the left hand side part and right hand side part. What is the left hand side part? So let us understand it through this example. First, suppose if I ask you what is the base for 96. So base for 96 is 100, right? So what we do in the left hand side, left hand side in this case will be deficiency, that this number is 4 less than 100, right? I hope you got it. If I ask you what is 96, so 96 is 4 less than 100. So left hand side will be 96 minus 4. I will subtract that deficiency which it has from the base. So the left hand side will be what? It will be 92. And what will be the right hand side? So right hand side is just the square of the deficiency term, that is 4 here, because the deficiency is 4. So 4 square is equal to 16. So the right hand side is 16. So the answer for this will be 9216. One thing that we need to be careful about, that the number of digits in the right hand side should always be equal to the number of zeros in the base. So here we noted that in the right hand side there are two digits, 16, 1 and 6, and in the base there are two zeros, 0, 1 and 0. This is two zeros are here. So that is what we need to be careful about. So let us solve some more problem to get the concept clear. So suppose I ask you what is 993 squared. So what will be the left hand side? Left hand side will be 993 minus 7, because this number for this number the base is 1000 and this number is 7 less than 1000. Okay, so we have to write 993 minus 7. And what will be the right hand side? Right hand side will be the square of 7, that is 7 square. So this will be what? 993 minus 7. So if I subtract 7, it will become 986, and 7 square is basically 49, right? But I told you that we also need to be careful about that. What is the number of zeros in the base? So there are 3 zeros in the base here, because this number is closer to 1000, and in 1000 there are 3 zeros. So in the right hand side also there should be 3 digits. So the answer will be 049. So the left hand side is 986 and the right hand side is 049. So the correct answer is 986049. I hope you got it. If I talk about this, here the deficiency from the base. So what is the base here? The base here is 100. So I will be first subtracting 88, and it is 12 less than the base. So the left hand side will be 88 minus 12, and the right hand side will be 12 square, right? So here it will be what? It will be 76, right? And right hand side will be 144. But here you note one important thing, that the base is 100. So in the right hand side, how many zeros should be there? How many digits should be there? 2 digits should be there. But here we have 144, that is 3 digits. So what we do? We take 1 here in the left hand side. So if I add 1 in the left hand side, the 76 becomes 77 and this becomes 44, right? So this one term is carried over in the left hand side. Now let us do this problem slightly bigger. So what will be the answer here? The answer will be 9987 minus 13. I hope you got it. This is the left hand side, and right hand side will be 13 square. So 9987 minus 13 will be how much? 7 minus 3 is equal to 4, and 8 minus 1 is equal to 7. So this is 9974. You can calculate 87 minus 13 is equal to 74. And the right hand side will be 169. But for this number, what is the base? For this number, the base is 10,000, right? I hope you got it, because it is closer to 10,000 and the deficiency from 10,000 was 13. So that is why I have taken 13 here. So there are 4 zeros in 10,000. So in the right hand side, there should be 4 digits. So how can we make 4 digit? We can add 1 0 before 169. So it will become 99740169. I hope you are clear about few points here. First is, what is the base and how many zeros are in the base. The right hand side should have equal number of digits as the number of zeros in the base, right? If it has something more, then we will take that in the left hand side as a carryover term. If it has less, then we will be prefixing it by 0, so to make it having equal number of digits as the number of zeros in the base. Okay, now let us look at this problem. So it is not very different, but just one thing is that here we are having the numbers which are greater than the base. So here if you talk about 106 square, so there is a small change in the process. The change in the process is, now this number 106 is 6 more than the base, because base here is also 100. So here also the answer will be written as the left hand side, right hand side. And what will be the left hand side? Left hand side will be this number that you are squaring and plus the surplus. So surplus here is, since it is 6 more than the base, so earlier I was subtracting and now I will be adding, because it is the surplus term. So that will be the left hand side, means 112. And what will be the right hand side? The same thing, the square of the surplus, that is equal to 36, right? And this important point, that the digits in the right hand side should be equal to the number of zeros in the base, that will be valid here also. So the answer will be like 11236, because in the base there are 2 zeros and in the right hand side there are 2 digits, so there is nothing to be changed here, and so this will be the correct answer. Okay, I hope I am making sense to you. So to understand this, let us quickly solve this problem. 112, so what will be the left hand side? 112 plus 12, I am writing for your understanding, and the right hand side will be 12 square. So this will be like 124, and 12 square is 144. Now the problem here is that it has 3 digits, but 112 is near to the number 100, so base is having just 2 digits, 2 zeros. Base is having just 2 zeros, so this should also have just 2 digits. So what we have to do, we have to take the 1 in the left hand side as the carryover term. So 124 will become 125 and it will become 44. What will be the answer here? Should I write directly? The left hand side will be 1 0 0 and 12 plus 12 24, and if I square it, let me write it separately. So 12 square will be 144. But how many zeros are there in the base? Here the zeros in the base are 4, because and the digits in the right hand side are just 3, so I have to put 1 extra 0. So the answer will be 1 0 0 2 4 0 1 4 4. I hope you are getting. What will be the answer here? The answer here will be 1026. Why? 13 plus 13 26, and then 13 square, that is 169, right? So that is the answer. Here the number of zeros in the base are 3, because and the number of digits in the right hand side are also 3, so we don't have to do anything. So that is the answer. So I hope the process is clear. I hope I have made sense to you. There are 3 special types I have discussed. When the number was ending in 5, then I just have to multiply the digits before 5 by 1 more than that, and then the last term, the right hand side, will be 25. If the number is below the base, then we subtract the deficit number from the number, that is left hand side, and then we take the square of the deficit, and that we put as the right hand side. One thing that we need to be careful about, that the number of zeros in the base actually should be equal to the number of digits in the right hand side, right? Because the base is already defined, so means the number of digits in the right hand side should be equal to the number of zeros in the base. And when we have a number greater than the base, then we just add the surplus and square the surplus and write it as left hand side and right hand side. So I hope you understood this process. In the next video, I'll be talking about the general term and duplex process, and in that you will be able to understand that how to find the square of any big digit number, any large digit number, and also how to find the last 3 digit, last 4 digit of any number. So that is all for this video. Thanks for watching. Please do like in case if you have understood something, and share it with your friends as well. Thank you.